That galaxies were speeding away from us was a discovery as striking as it was baffling. But unknown to Slipher and Hubble, an explanation was being formed by an obscure German physicist. His new model of the universe would be no less radical than those of centuries past, and among its predictions would be the revelation that the universe is rapidly expanding. All the more remarkable was that this insight came from a man now working as a patent clerk because he had shown so little academic promise. His name, Albert Einstein.
He was forced to learn a lot of very complicated mathematics in order to do so, but in 1915, finally, the theory was born. The theory was called general relativity, and it differed from the theory of gravity that had held sway up until then for more than 200 years, which was Newtonian gravity. And in Newtonian gravity, all objects in the universe attract each other directly. Einstein's theory of gravity is radically different, in fact, that the objects don't attract each other directly at all. One object makes dents or dimples or warps in the fabric of space-time itself, and the other object, as it moves by, is actually bent by the curvature of space-time, by the fact that there's this dimple there. And it looks like it's being attracted to the first object, the object that's making the dimple, but in fact it's not direct, it's just reacting to the warpage of space-time. So one thing to understand about general relativity is that you can't have a whole collection of matter, say of galaxies or stars, which are sitting in static configuration with respect to each other, and expect them to stay there. They won't. They're going to collapse in towards each other. So this means that you can't have a static model of the universe in general relativity. The universe either has to be expanding or it has to be contracting. It has to be dynamical in some way. It can't possibly be static.
Einstein imagined that there must be some unknown force keeping the cosmos from collapsing in on itself. In fact, he had predicted that the universe is expanding.
And the astronomers looked at Slipher's discovery of the motion of the galaxies and the prediction that the universe expands, and they said, aha, these are two sides of one coin. They fit together. And Hubble, again with that golden touch for working on the big problems, turned his attention to this question, and he asked himself, how can I investigate it? And the way he did so was to start to measure the redshifts, as they're called, the velocities with which these galaxies are moving away from us.
Hubble began the painstaking process of comparing the distance and redshifts of dozens of galaxies. The results were staggering.
And he found something known today as Hubble's Law, quite extraordinary, that the redshift, or the velocity of recession from us, is proportional to distance. If a galaxy at this distance is moving away from you at a certain speed, a galaxy twice as far away will be guaranteed to be moving away from you at twice the speed. Hubble actually changed the picture of the universe because the Ptolemaic picture was static and Newton's picture of the universe was static. But Hubble showed that the universe is dynamic. Everything is moving away from everything else. Greek astronomers thought, most of them, not all of them, that the Earth was the center of the universe. Copernicus showed that that was not so and thought the sun was the center of the universe. Other later astronomers showed no, the sun was not the center of the universe, but many of them thought that the center of our galaxy was the center of the universe. Hubble showed that there is no center, and that was a tremendous scientific, theological, and philosophical accomplishment. He showed that the universe, as far as the telescope can see, is populated with countless numbers of island universes, and there is no difference whatsoever. There is no center. The second implication of his finding was, well, to explain it, imagine that the picture of the expanding galaxies moving away from us and one another is a movie strip. Now run that in reverse, and all the galaxies going backward in time come closer and closer together. And finally, they all meet together at one point, speaking loosely, because there is no one point, there is no center in the universe. They all come together. in an infinitely dense yet infinitely extended moment, and beyond that, of infinite density, one cannot go. So that moment marks the beginning or the birth of the universe. And all of the things that we see around us, every star, every planet, every living thing on the earth and in the cosmos, owes its genesis to that moment. You can call it the Big Bang, but you can also call it, with accuracy, the moment of creation.